Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP ENARSI version 8 course curriculum. And in this packet tracer activity, we're going to close out our coverage of OSPF version 2 with packet tracer activity 8.2.1, where we're going to troubleshoot multi-area OSPF version 2, meaning and implying OSPF with IPv4. So let's go ahead and dive into the activity here. You can see we've got multiple areas that we're going to be dealing with. We have our backbone area, area 0. We have area 1 to the left in yellow and area 2 to the right in light blue. And here's our addressing table that we may be referring to. And you'll notice that this activity does not have a scoring sort of indicator down here in the lower right. And that's because this is going to sort of walk us through what's going to be required to fix the topology, and then I'm going to add some value by talking about some other things that you may or may not see in your OSPF v2 travels. So the first thing it wants us to do is it wants us to focus on area 1, and specifically by taking a look here at router number 2. So if we're on router number 2, let's go from user exec to privilege exec using the enable command. And what if I was to try to ping the 209.165.200.16? So again, we're going to go right for trying to get out to the internet. Now, what we're going to see here is that this is obviously not going to work, because this is one of the things we're going to have to fix. And so let's go ahead and say show IP route. What does my routing table look like right now? Well, this should also be sort of a red flag because we don't see any OSPF learned routing information. Now, if we're in a multi-area OSPF configuration, we would expect that we would see some type of OSPF routing information that's been learned. All right, so let's go ahead and say show run and pipe that to section router OSPF. They wanted us to take a look at the OSPF config, but we could also say show IP OSPF neighbor, right? And as you can see, we don't have any OSPF neighbors. Now, we do have an OSPF configuration section. We've got our router ID configured in there, and we have 2 network statements. However, we don't have any OSPF adjacencies with any other neighbors. And so step B says, let's take a look at the show IP OSPF interface command to show us the OSPF interfaces. As you can see, loopback 1, which is that 192.168.4, for which we do have a network statement right up here, and it is in area 1. That has been defined. And then the gig 00 interface has also been defined. Now, we're going to add some value talking about that broadcast network type here between router 2 and router 1. And my question to you is, does this need to be a broadcast network type? In other words, do we need to have a DR-BDR election when 2 routers are connected via an Ethernet cable in a back-to-back configuration? And the answer is no, we don't. So what we could do is we could change the network type on the gig 00 interface for router 2 as well as for router 1 so that there is no DR-BDR election. And you can see right here, the designated router is me, router 2, right? And then there's the interface address for the designated router. But do we need to be generating these type 2 LSAs? No, the answer is that we don't. And so we'll fix that here in short order. So it says if the R2 configuration and settings are correct, the problem of not forming the adjacency must be on router 1. But before we go to router 1, let's go ahead and come into router 2 and a couple things that we would want to do. So if I say do show run section router OSPF, you can see that we're missing some things that I typically recommend. So let's go ahead and say router OSPF 1. I'm going to say passive interface default, and we're going to say no passive interface Gigabit Ethernet 00. Gigabit Ethernet 00. Now I'm also going to go under the interface Gigabit Ethernet 00, and we're going to say IP OSPF network, and we're going to make this point to point. Because again, these routers are connected in a back-to-back fashion. In other words, directly connected to each other. It's not as if they run into a switch and there's some sort of multi-access broadcast domain that's taking place here where we've got 5 or 6 routers connected where we would want a DR and a BDR for scalability in a broadcast network type. That is not what we have here. So I'm going to say IP OSPF network point to point. And we're going to do that on the other side as well. So let's go ahead and say end. Let's give it a write mem here. And then let's come over to router 1. So here we are on router 1. And as you can see in the instructions, they gave you the information that would need to be considered in order to make a fix here. But let's take a look at how we might come upon that information. So I could say show run pipe it to section router OSPF. And here is where we would see the passive interface gig 00 command. Now, we could also, as they recommend, you could do a show run. However, this, I think, is just a little sloppy in terms of trying to get to what it is you're looking for. However, with Packet Tracer, there are times when you're going to have to say show run to get to something. So in other words, if I said show run int gig 00, you can see that it doesn't support that command. And so then that's where I would have to say show run so that I could walk down here to see, okay, is the right subnet mask on there? What are we looking at? You know, you could say show IP interface brief, not going to give me the subnet mask, but it certainly gives me how the interfaces are set with IP address. So again, you'll approach things differently on real Cisco routers as you would in Packet Tracer. I'm just going to show you some variations as we work our way through. So here's what we've got. Router OSPF1, the router ID is set. Log adjacency changes is on auto-magically. And then here is the problem. We've got this passive interface, Gigabit Ethernet 00. Well, that is the interface out which router 2 is, or I should say router 1 is communicating and connected to router 2, and it clearly shows us that that interface should not be passive. So let's do a few things here. Let's get into global config. Let's say router OSPF1. Let's do that again, router OSPF1. And I'm going to go ahead and say passive interface default, and that's going to take down the adjacency with the ABR, but that's okay. We're going to sort that out here in a second. We're going to say no passive interface gig 00, no passive interface gigabit Ethernet 01. So now let's say do show run section router OSPF. And as you can see, the adjacency with the ABR, the area border router, the router that borders area 0, the backbone area, and area 1, the non-backbone area. And that adjacency is now up. But what you'll notice, if I was to say do show IP OSPF neighbor, that we're stuck in the two-way DR other state with router 2. And again, neighbor ID, that's the router ID. And you can see that it's going to go from loading to full, but we're going to have some issues here, right? Because it's going to get stuck in that two-way state because the network types are different. And so OSPF is throwing that up there. If we say do show IP OSPF neighbor, you can say full DR, and that is not where we should be, right? Because there should not be a DR BDR election taking place here on that interface between router 1 and router 2. And so what we need to do is get into int gig 00 and say IP OSPF network point to point. Now, you can see that the adjacency goes from full to down, and then we came from loading to full. And so the adjacency is now back up. So if I was to say do show IP OSPF neighbor, you can see here that the priority defaults to the default priority for an OSPF point-to-point connection or network type, priority of 0. The state we are fully adjacent with router 1 and router 2, And the dash represents that there is no DR BDR election. If I say do show IP OSPF interface, and let's go ahead and trim it to the gig 00, you can see now that it is point to point, right? And this is what we would want to have happen. Because again, these routers are connected back to back. Now, we can make the argument that we could do that here, and absolutely we could, but I'm not going to belabor the point. I've showed you how to do it between router 1 and router 2. This is something that when you have these back-to-back connections like this with Ethernet cables and you end up with a broadcast network type, you would want to go ahead and change it to point to point. Again, if it's getting plugged into a switch, into a VLAN, where there's multiple OSPF speakers, then you want to have the broadcast network type and let it default out to that, because we do need the designated router and the backup designated router in that scenario for OSPF scalability. All right, so that takes care of the adjacency between router 1 and router 2. And now over here on router 2, let's say show IP route. And as you can see, we're seeing various OSPF routing information. We're learning intra-area OSPF routes, right, by the O, and then inter-area, so between areas. And again, you've got like a little secret decoder ring right up here. So the O by itself stands for an intra within the same OSPF area route, and the OIA stands for an inter between area OSPF route. Now this OE2 down here, we saw this in Packet Tracer 722. That is the default route, and the route that we're learning that is being originated from the Autonomous System Boundary Router. And you will also hear this referred to as Autonomous System Border Router in OSPF. Those, you can think of those as synonymous terms. It's just simply two different ways to say the same thing. It's the ASBR. And it's an ASBR because it is connected to a router that is outside the OSPF routing domain, which is this ISP router here, meaning that this is going to be the router that is going to originate or advertise the default route, telling all other OSPF speakers, router 2, router 1, ABR1, ABR2, router 3, and router 4, that if you do not have a longer, more specific match in your routing table, let's bring that traffic here. And you can see that router 2 knows that it's simply going to send that any traffic for which it does not have a longer, more specific match, it is going to send it to the 192.168.2.1 out gig 00, and that is router 1. Now, these OIA routes we're learning from other areas. In fact, if we look at some of the 172 information, are there any loopbacks over there? I don't think they did loopbacks on that side, but what we see is the 172.16.1.0/25, and that looks like that might actually be a mistake now that I'm looking at it. And we're only seeing one 172 network. Now, again, there's probably some more errors over there, but just driving home the point that that would be an OIA, right? It's coming from another area that this router is not connected to. Now, with the ABRs, it's important to point out that if I was to say here on ABR1, and let's get into privilege exec, show IP route, you can see that the only inter-area route that it currently sees is to this 172.16.1 network. Because the information over here in area 1, it will see as intra-area OSPF routing information, not inter-area. It's intra because the ABR has an interface participating in area 1, which is why you see O's for the 192.168.4.1, which is the loopback address, I believe, of router 2. And we can quickly check that with a show IP route. I'm sorry, with a show IP interface brief. And it is 192.168.4.1. And so area 1, router 2, if it doesn't have a longer, more specific match, is going to be leveraging the route that is being advertised or originated. So we'll say show run and then pipe it to section router OSPF. And there is your default information originate statement. And there would also be show IP route, a statically configured route, default route that points out the gig 00 interface. It just basically says, hey, shove all traffic out this interface to the ISP if we don't have in our OSPF routing domain a longer, more specific match. All right, so that takes care of the problem. We did get some syslog messages. Now let's check out what's going on over here in area 2. So the network's lost contact with area 2. And actually, before we do that, if I was to jump here on router 2 real quickly back in area 1, let's see, can I get to the 209.165.200. And you know what? I looked at that. Is it not? I don't believe it's 16. What is the ISP? It's 17. Sorry, I think I typoed that earlier. We would have never gotten there anyway because we didn't have the default route. But now can we get to the 209.165.200.17 and take a look at that? We now have connectivity from router 2 out to the internet. All right. So does the ABR2 routing table show the presence of the 172.16.164/24 and 172.16.196.24? And so if we were to come on to ABR2, let's go ahead and take a look at that. And let's say show IP route. So do we see that 172.16.164? We don't. We see a 172.16.132, which is the transit segment between the ABR, the area border router, ABR2, and router 3. And we see that because we are directly connected to it. But what we do not see is we don't see these two other networks that they're referring to here. And so that's going to lead us to believe that either there is no network statement or that the network statement might be misconfigured in some form or fashion. So the first thing I always like to do, if I'm wondering about, hey, is OSPF functioning properly here on this router? Am I getting all the routing information? Take a look at show IP route, but then a show IP OSPF neighbor, right? So who are my OSPF neighbors? So I've got a point-to-point network type because it's a serial connection between ABR2 and the autonomous system boundary router. And that is fully adjacent. And then with router 3, it shows that we are fully adjacent. And again, there's been a DR-BDR election that has taken place here. You can see the default priority is set because it is a broadcast network type. How can we see that? Show IP OSPF interfaces, right? So network type broadcast cost 1 because it is an Ethernet interface. It's a gigabit Ethernet interface. And then down here on the serial interface 001, it is point-to-point. And since it is a the equivalent of a T1, we've got a cost of 64. So that's obviously not the problem. So, and again, it says right here, because ABR2 has formed a neighbor relationship, the problem may lay with OSPF configurations on router 3 or router 4. And so let's pull router 3 up here and let's get a look into what might be going on. Let's say show IP OSPF neighbor, because do I have a neighbor adjacency with the ABR2 and router 4 to whom I should be adjacent with both of those routers? And so we see the router ID here, and we see it's out gigabit Ethernet 01. So I could say show IP interface brief, and this is going to show me that the gigabit Ethernet 01 interface is the 172.16.1.62. And so it looks like there might be an issue going on here with this IP address. We see that we're up with gig 02. And let's go ahead and see. And again, it's going to give you the answer down here below. But to correct the problem, replace the OSPF routing process network statement for the 172.16.164.24 subnet in area 0 and change it to area 2. But before we do that, what we would do next here is we're going to say show run pipe it to section router OSPF. And let's see how router 3 is configured. So here is the network statement set up, and it lists area 2. And you can see that that is actually correct because, again, the ABR, that interface is participating in OSPF area 2. And router 3 is properly configured. And so, again, we could come over here to ABR02 and say show run pipe it to section router EIGRP. We could have looked at the output that's right above us here to see the router ID. Oh, EIGRP, sorry, OSPF. But checking to see which router is the 6666, to which this router says, hey, I'm fully adjacent. And so the connection here is good. You know, we're good with router 3, right? So then the issue lies here. And when we look down here, we can see that that might be the problem. And this is one of the things that must match, is if these two routers, ABR2 and router 3, are connected together, and OSPF is active on both interfaces, and we want the adjacency to form, which we would because we're running OSPF, the area must match. And so between router 3 and ABR2, it matches. It's area 2. But what about between router 3 and router 4? What if I was to do a debug IP OSPF events, and then we'll say, and actually let's leave it here for a second, and let's see if we get the mismatched area type. Because what's probably going on over on router 4 is that, and let me throw in the debug IP OSPF adjacency. So what we should see is that there are mismatched area numbers. Again, I'm assuming router 4 is configured and configured properly, and we may not get what we're looking for here between these two routers. And while we wait for that, let's take a look at the configuration on router 4. Let's make sure router 4 is configured for OSPF and is configured proper. And here it is. So we see, as I'm straightening the window out, I'm like, fantastic. All right, so you can see that router 4, we're getting the syslog message, invalid packet, mismatch area ID. Because on router 3, and let's kill all debugging, show run pipe it to section router OSPF, we see that the network statement there is set for area 0. Over here, if I was to say show run pipe it to section router OSPF, you would see that the interface between router 3 and 4 on router 4 has a network statement, but that interface has been placed into area 2. Not area 0, and it shouldn't be area 0. It should be in area 2 because that's the area that we're operating in. So let's come over here to router 3. Let's get into global config. Let's get into router OSPF1, and let's go ahead and say no network 172.16.1.64.000.31, and the wildcard mask for a /27. This is correct, so there's nothing wrong with our wildcard mask. Area 0, and then let's rerun that for area 2. And then I'm just going to scoot back here, save a little typing, and we should see that the adjacency comes up. Again, between the ABR2 and router 3, you would get on those, you would want to get on that gig interface, whatever it is, for both routers, and change that to point to point. We don't need a DR-BDR election there. And the same is true between router 3 and router 4. We don't need a DR-BDR election. Those routers are connected back to back via an Ethernet cable. So we can do that. We would also passive interface default or passive the interfaces that aren't going to be OSPF interfaces over which we're going to be forming an OSPF adjacency. So I always kind of go with passive interface default and then passive any interfaces that need to be passive. So for example, on router 4, we would look to passive this interface here because router 4 is not forming show IP Ospf neighbor. It should have a single neighbor. Router 4 is not forming an OSPF adjacency with switch 1, right? That's not a multi-layer switch. We're not running OSPF on it. So we would passive that interface because it allows us to advertise the network on that interface here on router 4 that connects to switch 1, but it's not going to be sending OSPF hello packets. That's what the passive interface is accomplishing. We don't want OSPF hellos being multicast out this interface because we don't know, how many PCs are hanging off of this switch, who can see that information. Maybe someone's got Wireshark installed and they're doing a packet capture. We don't want that information to be shared. And a takeaway from video or from Packet Tracer 722 is what else would we do to secure the OSPF communications here between all of our OSPF speaking routers in the OSPF routing domain? Exactly. We would want to configure authentication, cryptographic type 2 authentication between these OSPF speakers. All right, so let's take a final test here. If I am correct, if I say show IP route, I should see, and we should actually be seeing more routing information than that. Let's take a look here. So it went from loading to full. Let's save our config, and let's say show IP route OSPF. So this might be an issue here. Oh, yeah, okay, so it appears that router 3 is missing the OSPFv2 inter-area. Summary route. To solve this problem, completely remove the routing process. Oh, okay, so for router 3, they want us to do sort of a wholesale thing here instead of fixing. I just went after that single statement there. And let's see, show run, pipe it to section, router OSPF. So we've got the correct statements there. The router ID is set. And we are... They wanted us... I think that's interesting that we have the correct statements in there, but they want us to wipe it out. And maybe this is a function of Packet Tracer. Hold on one second. I want to see something here. Show run section router OSPF. 172.16.132, and so that's correct. Okay, so we're going to go ahead and do what they're requesting here, and so I'm going to say no router OSPF1, and that's going to take the adjacency down between router 3 and ABR2 and router 4, because again, we just wiped out the OSPF configuration section. So let's go ahead and say router OSPF1. Let's get our router ID in there is 3333, which is what it was before. Log adjacency changes, again, that's going to be in there by default. 172.16.1.32.00031, area 2. And that is up, and then all we have to do here is change the 32 to a 64, and that should bring up the adjacency between router 3 and router 4, and hopefully that's going to be taking place here shortly. And there we go. We'll do a quick write mem, show IP route OSPF, and now we do pick up the summary route. Again, we should have picked that summary route up without, and again, I want to make sure I'm clear on that. This has got to be something to do with Packet Tracer, because typically you're not removing your entire OSPF configuration section in order to receive a summary route that would be coming to you from show run section router OSPF. And there it is, the area 1 range command, right? Remember, with summarization in OSPF, you can do it at the ABR and you can do it at the ASBR. That is it, right? You do not want to be doing summarization anywhere else. It has to be on the area border router or the autonomous system boundary router, and it's done differently on the ABRs as opposed to the ASBR. However, keep in mind that to summarize, that is where it's going to have to be done. And so here's our area 1 range command. And again, I find that odd that I would have to completely wipe it out. And that's not something that you're typically going to have to do. Again, let's go ahead and wrap this up with a quick ping out to the 209.165.200.17. Let's make sure we get that IP right. And let's go ahead and check. And there it is. We've got reachability out, show IP route. I get the default route, and can I ping over to 192.168.4.1, the loopback address on router 2? And so we've got full connectivity all around the configuration, and that is going to do it for this packet tracer tutorial 8.2.1, where we were troubleshooting multi-area OSPFv2, and we saw a lot of the common mistakes that will happen. Mismatch area numbers, missing network statements, wrong network statements, and again, they did a nice job of walking you through here, and also watch out for those passive interfaces. And then we added in, we spiced it up a little bit by talking about that IP-OSPF network point-to-point statement, and why and when you would use that, and why and when you would not use that. If it's a broadcast network type, the router's plugged into a switch that's in a VLAN, and you've got multiple OSPF speakers. All right, as always, thank you so much for watching. All the best to you in your studies, and I hope to see you in the next video.